Imagine a world restricted by age, a prison of disease, blurring and slowly fading away. A distant memory of a life you once had, the window to your soul, now but a byproduct of age, a relic. What we take for granted now in 2050 was once just a dream on the horizon for humans, a slim possibility of occurrence, glimmers of hope and mountains of failure. We explored the beginnings of one of humanity's most ambitious projects, understanding and replicating the human visual system.
The structure of the bionic eye isn't what you see today. This fully functional eye was once just a tiny computer chip implanted by highly invasive surgical procedures, sometimes further damaging the eye. This now museum building was one of the first labs these chips were actually designed in and tested in. We're now walking to one of the old labs. And as you can see, this is a restricted area only, and you need permission to enter this place. This is where one of the old testing places in which the students designed and tested the implants. This is the main laboratory in which all the students implanted and tested the chips.
Professors.
And this is where the professors stayed in and designed the chips.
For a while, after the initial discovery of the ability to stimulate the brain, they actually tried to put chips in the brain. Silly and far-fetched ideas, most likely too much Star Trek from our very nerdy scientists. However, since the cortical implants required intracranial surgery, which at best was a mixture of medieval equipment and apparently educated guesses, bionic eye development was largely focused on retinal prostheses. The retina was a desirable place for stimulation because it is the earliest site of potential neural interface. The retinal-based visual prosthesis essentially replaces the function of degenerative receptor cells by stimulating the surviving ones. The fact that the retinal prosthesis is only able to stimulate surviving cells means that only individuals suffering from retinal diseases, such as age-related macular degeneration or retinitis pigmentosa, were actually able to benefit from this implant, severely limiting its usefulness to humanity.
An incredible stroke of luck by our team led to the discovery of a body in an abandoned lab in North Korea, preserved and in impeccable condition due to a volcanic eruption. Each eye was found to contain different retinal implants. On further investigation, we found distinct differences between the two. One was subretinal and the other was epiretinal.
This room right here was completely preserved since the initial volcanic eruption. Completely preserved. Nothing has changed. Absolutely nothing. What we're actually going to do is we're going to take a first look at its state. We're actually having a look at what is inside. So just come over here and follow me right in. Don't touch anything. It's very valuable. Just come right in. As you can see, there's no one inside. It's been completely preserved. We actually have a body. That's been completely preserved. As you might see, this scientist was sleeping and a prank was played on her by her friends. Now, we're going to actually have a look at the chip inside her eye. It's fascinating. Each eye has a different chip. So, just have a look over here. So, what I'm going to do is I'm just going to have an initial look. Now, what I need to do is just bring the camera right over and just get that lens in. And what you'll be able to see is a chip inside her eye. It's actually incredible.
The implants found in the preserved body were not very different from those being developed by the BVA team in Australia almost half a century ago. Two models were in development at the time. The wide view model was low resolution and was trialled in 2012. It was quite a big success at the time. Believe it or not, it had only 24 electrodes and it was all electronics and chips, but it represented a leap forward in curing blindness. The second was a more complicated attempt and was going to really allow the blind people to see at a comparable level to the rest of society. From the records that survived, it seems as though this too was a success, but we can't be sure. What we do know is that it presented a platform for many more advanced models to be developed.
During our extensive research on the retinal implants, we came across some lost footage which seems to have been from the year 2010. It was some pretty old stuff, and with the fall of YouTube, it only made finding this piece of history that much harder. Have a look at what we found.
This group of researchers work at the interface of engineering, medicine and biology. A 10-year development underway to create a bionic eye. This is the map of what will be contained in a tiny neurostimulator chip.
So this work took about 3 or so PhD students, about 6 months of their lives to do. There's about 1 million wires there, and it's about one of the most complex neurostimulation chips ever designed.
Its size is only 2 by 4 millimeter.
So this chip is not mounted on this carrier package, but what happens is it's turned upside down and mounted on this carrier. So in terms of the technology, we'd have an external camera and a processing unit that would send signals and power to a device that would be implanted inside the eye. There'd be electrodes at the back of the eye on the surface of the retina, and they would be electrically stimulated, and they would then convey information down the optic nerve to the brain, to the visual cortex of the brain. And we believe that the brain would be able to interpret those signals, probably remodel some form of visual image.
These dotted images show what a person might see when using a bionic eye.
I think to create a bionic eye is equivalent to trying to create a television as compared with a radio. I mean it's of orders of magnitude more complex to create a bionic eye. It's an enormous task, but we've been doing it for 10 years, and we believe we have probably the most advanced electronics technology that is in use today around the world.
The video tells us of how extremely exciting it was to create the bionic eye. They had hope and determination to build a device that could potentially bring back vision for blind individuals. There are many advantages of this incredible idea. Bionic eyes gave individuals a general sense of vision of their surroundings, almost immediately enhancing their quality of life. The procedure was far simpler than cortical implants. So instead of doing this, we put the camera, we did this. The implant chips were very durable, and it was waterproof and corrosion proof and caused no harm to the eye. The bulk of the device, such as the camera and the glasses, sat outside the eye, therefore caused no harm to the body. This was the cutting edge of medicine and technology at the time.
Truth, man. With advantages came disadvantages. The bionic eye was believed to have only benefited those who suffered from specific diseases, namely degenerative retinal diseases. Therefore, those who were born blind couldn't benefit from such a device because they never had functioning eyesight. Glaucoma, which affects the optic nerve fibers, couldn't be overcome with such a device. To think that glaucoma could be so destructive is almost unthinkable now. But just 100 years ago, a simple infection could have destroyed a person's life, most resulted in death. The evolution of medicine and treatment is slow, but is constantly moving. So while the ideas were grand, potential huge, the reality was that technology and medical techniques had not yet advanced enough to completely restore vision, rather only allowed rough visual sensations.
The ideas bouncing around 50 years ago were incredible. People wanted to change the world, bring back what was once thought to be impossible. Vision, a dream for so long, now a reality. But it was a combination of intellectual brilliance and extreme commitment to the project that allowed it to flourish and become what it is today. What is profoundly special about this field, about this project, is that the goals have never changed, never wavered. A goal the world knew little about and governments were at times hesitant to support, grew to become integral to the very fabric of society. Vision, understanding it, manipulating it, and restoring it. Those are the goals and have been since the beginning, until now.